Hey there, Mathies. Let's talk about this week's math. We are going to cover the law of sines and cosines. So this video should be a little bit shorter. Make sure you print out your notes, and then you'll see that there's just one brief assignment this week. We're gonna scale it back a little to not only cover new content, but give you time to catch up on anything you might need to from the last few weeks. So, law of sines and cosines. It is different than the unit circle because now we are getting away from perfect right triangles and we are now dealing with non-right triangles. So just because we are still going to use sine and cosine, but in a slightly different way. And this will allow us to solve a triangle. So meaning finding all the missing sides and angles of a triangle, even when it's not a right triangle. So we can't use Pythagorean theorem here, and we can't use SOHCAHTOA. But we are gonna use a different version of sine and cosine so that we can actually find missing things. And the truth is, in real life, very few things are perfectly square or perfectly right, 90 degrees. So that means that we often use these formulas more than we would SOHCAHTOA. So this might actually come in handy, some of you that are interested in, construction or engineering of any kind. I've personally used this when we were working on putting trim up in our house and I had to do some measuring. So kind of a nerdy side note. All right, so your formula here, law of sines, just know that we can take any two of these ratios and set them equal to each other. So that's why it looks like a weird three-piece equation. It's not. It's just saying that you can take any two of these and set them equal to help you solve for a missing side or angle. Law of cosines, I'm only giving you one equation. Sometimes when you see it written out in a book or something, you'll see that there's actually three equations, but I feel like that's just too much and it's confusing. This one equation, all it's saying is that the little side A and the angle A should be on opposite sides of the equation, but let's say you're looking for angle B. So you would make that capital letter a B, and then you would make sure the little one is a B, and you would just put A and C right here. So I want you to just understand that you can rearrange the A's, B's, and C's however it works, as long as the side and the angle are on opposite sides of the equation, meaning if it's an A here, it should be an A here, B, B, C, C, right? When we're looking at a triangle and we're looking at the labels, capital letters are always the angles, and then the sides are always marked by lowercase, and you should also note that capital C and lowercase c will always be across from each other, capital A, capital B, lowercase b. So hopefully that's making sense. So really that is it. That is what we want you to use. Now I'm going to show you some examples on how to use it. So these are your formulas. This is just kind of some side notes just to understand going into the questions, how we label things. And remember, these are all non-90 degree triangles, non-right triangles. All right, so let's look at this first one. I'm going to be asked to solve the triangle, meaning I need all the missing sides and angles that aren't here. Well, in order to do that, I need to decide which one of these to use. Now, don't worry if you're kind of like, well, how do I know? I will tell you right now that if you're given an angle and its opposite side, you automatically can jump into law of sines. If you don't have an opposite side and angle information, you want to use law of cosines. But if you go to set it up, if you set up law of sines and you notice you have more than one variable, that should tell you that that's not the right formula. Jump to the other one, all right? So in this case, I have a side and its opposite angle. I have numbers. So since there are numbers for both of those, we can use our law of sines. So let's set it up. And the way we do it is we say sine of an angle. So in our case, that would be sine of 115 over little a, so over its opposite side, right? So 49 equals sine of, and we can pick another angle, right? But notice we have this side right here, the 16. So let's pick the side or the angle across from the 16. So we'll say sine of a over 16. So now you have one variable, and we're going to use our calculator to find all of this other stuff, and you absolutely need a calculator. So you can use your phone calculator. It's not a problem if you don't have a scientific or graphing at home. It's no big deal. I would show you on my phone, except that I'm using it to record, so I can't do that at the moment. But if we take our calculator, we want to make sure you're in degree mode. And so that's because we're doing everything in degrees. So even on your iPhone calculator, when you turn it sideways, there's a little button in the bottom and it says rad, R-A-D. You don't want it to say rad up in the screen, so make sure it says degree. All right, so we're going to find sine of 115 degrees. So you hit sine 115, and that's equal to the 0.906. We divide it by 49, and that gives us 0.0185 if I round to the nearest fourth decimal place. Okay, that's equal to sine of a over 16. Remember, the goal is to solve for a, right? So I'm going to multiply it by 16 over to this side. So times 16 gives me 0.2959. And that's equal to sine of a. Now I need to still get a by itself, and the only way to do that is to do the sine inverse of this value. Remember seeing that back in Math 2? So sine inverse of 0.2959 will equal a. So I want you to look at that for a moment. What I did in order to get a by itself is I took the inverse sine function. And so we do that, if you see on your calculator, on your iPhone calculator, you hit the second button. So even on this I do. So second sine gives me sine inverse, that little -1, and then I say 0.2959. And that equals 17.2. So that means angle A is about 17 degrees. And we tend to round our angles to the nearest whole number. Pay attention to what they ask for in Pearson. They may say round to the nearest tenth, so your answer would be 17.2 degrees if that were the case. All right, so we now have angle A. We don't have angle B yet, and we don't have side B. So what I'm gonna do right now is I'm going to find angle B very easily by simply adding up the two angles that I have and subtracting from 180, right? Because we know that angles of any triangle add up to 180. So angle B is equal to 180 minus 115 plus 17. So let's do that in our calculator. So 115 plus 17, and I take that from 180 and I get 48. So that means angle B is equal to 48 degrees. So we can fill that one in now. And then the last thing we have is side B. Now, because it's not a right triangle, I can't use Pythagorean theorem, but I can use law of sines still, right? So I know that sine of 48 over little b equals, and we can go back to this one since we used it before, sine of 115 over 49. Well, what does sine of 115 over 49 equal? Well, I have that written down already, so that makes it a little bit easier. Oh, so sine of 48 over b equals 0.0185. Now, I want to go ahead and solve for b in this case. So if I multiply b over to this side, I have sine of 48 equals 0.0185b. And then I can divide by 0.0185. So I'm writing all these steps out so you can see it, but you don't have to. You can start plugging into your calculator whenever you're ready. All right, so sine of 48. So sine of 48 equals, and then divide that by 0.0185. And that is equal to 40.169, so we can just say 40 in this case. So b is equal to 40. So that means the side B that I'm missing is 40 units long. And that's solving the right triangle using law of sines. Okay, so let's do the same thing, only let's use law of cosines. And the reason I'm using law of cosines on this one is because notice what they're giving me. They're giving me an angle, and they're giving me the two sides that surround that angle. So I don't have an angle and its opposite side, so I can't use law of sines. And you would notice when you go to start setting it up, you would have too many variables in the equation to solve. So we're gonna now instead use law of cosines. So notice it's little b that I have here. So if you go to your equation, your law of cosines, that means I want a little b all by itself on my equation. So that would be a b squared here. So I'm gonna go ahead and swap out the a's and the b's. I hope that makes sense. So then I'm gonna use a for this b here and a for this b here. All right, so let's set up that equation. So b squared equals little a squared, so that's 5 squared, plus 2.2 squared minus 2 times 5 times 2.2 cosine of the angle that we have, 45. So pay attention to where I plugged everything in. Just take a moment to look at it all. And remember that we should only have one variable in the entire equation, and we really want the variable, if it's a side, obviously, to be by itself, right? You could have the variable here with cosine, but if it's anywhere else, it's really not going to be helpful to us. So we need it to either be alone or with the cosine. Okay, let's do what we can with the calculator. 5 squared is 25, 2.2 squared, we can do that. You can add those together, right? This is one big multiplication over here, so be careful. Don't multiply the 2 times the 5 times the 2.2 and then subtract it from this. You still have another piece to multiply. So just be careful. Those are common mistakes that I see you guys make a lot. All right, so 25 plus 2.2 squared. Actually, I don't like that. Okay, so that's 29.84. So b squared equals that minus, okay, so that's 2 times 5 times 2.2. That's 22, which is right out in front of cosine of 45. So now let's find cosine of 45, and that's 0.707. So that's 22 times 0.707. You can see these get a little messy, right? So we have, okay. These get a little bit messy with all the calculations, but we should be able to do them with our calculator, no problem. So 0.707 times the 22 is 15.55. So 29.84 minus 15.55. When we subtract those two, we get b squared is equal to 14.3. So now I just need to square root that to get the value of just b. So b is 3.8. So that gave me b. Now I just need to go back and find the angles that are missing. So now that you have the opposite side to this angle, we could use law of sines. It makes it a little easier. I think law of sines is quicker and easier to use. So I tend to use that as often as I can, but we could go ahead and use law of cosines if we need to. But I'm gonna set it up as law of sines. So sine of this capital B is 45 over little b is 3.8 equals sine of A, we don't know it, over little a is 5. So now we can go ahead and solve that using our calculator. So let's do that. I'm gonna take sine of 45, I'm gonna divide it by 3.8, then I'm gonna multiply it by 5, right? So if you worked it out step by step, you'd see that that's the order I would go in. So that is 0.9304 is equal to sine A. Remember, to get A by itself, we need to take the inverse of that. So inverse sine of that value gives me 68.5 degrees. So A is equal to 68.5 degrees. And we can round that to 69 degrees. Like I said, we usually do angles as whole values. So that would be 69 degrees. And now, in order to get the last one, we just add these together and subtract from 180. So angle C is equal to 180 minus 69 plus 45. All right, and that will give us 66. And that's solving a triangle, because we have now found every missing side and angle. So that was 3.8. All right. Okay, so the last part of this is when you are given a triangle and you have, let's say, an angle in its opposite side, right? And then another side. So this is, if you remember triangle congruence, when we would talk about angle, side, and side, and things like that, this case right here is angle, side. And remember, we're technically not allowed to deal with that. So that's what we call the ambiguous case. It means that there's two options for this particular problem. It means we're gonna have two sets of answers, okay? when that happens, we can use the law of sines, but we have an opportunity or an option of an obtuse angle and 2 acutes, or 3 acute angles for a triangle that has this as a starting setup. All right, so let's use law of sines. So we're going to do case 1, and then we'll do case 2 in just a moment when you have to use case 1 to get to case 2. So case 1, sine of 33 over 22. Okay, so that's the sine of angle B over little b, equals, now notice the other side I have is little a, right? So let's use sine of big A over 27 over little a. All right, let's do the math with our calculators. I'm going to try and keep this as neat here as possible, so I'm not going to write as much down. So I take sine of 33, I divide it by 22, then I multiply that by 27, right? So that gives me 7.35, let's see, 7.35 is equal to sine of A. Let me make sure I did that right. So sine of 33 degrees divided by 22 times 27. Okay, I had a feeling I did that wrong. That seemed way too big. So the answer is 0.6684. 0.6684. That's equal to sine A. Now, to get A by itself, we have to take the sine inverse of that value, and we get 42. So 42 degrees. It's 41.9, but I'm going to round to 42. All right, so that's one possible case. Now, the other possible case is that we actually found the outside of the triangle. So what we're going to do is case 1, we'll continue to work off of this, but for case 2, we take this 42 and we subtract it from 180. 180 minus 42. And that gives us 138. That means that angle A could also be 138. So then we'll work off of it as an obtuse angle as well. Okay, so first case, we know angle A is 42, we know angle B is 33. Now we can find angle C just simply by saying 42 plus 33 and subtract those from 180. And that gives us 105. So angle C could be 105. Or come over here to case 2, and angle C could be 138 plus 33 minus 180, right? So 138 plus 33, take that from 180, and you get 9. So angle C could also be a 9-degree triangle. So what's happening here is they're setting up 2 potential scenarios that could have these side lengths and then these different pairs of angles, and it would still work out. So what will change now is the side length of C. So now you can go back through, use law of sines to find little c in both cases, and then you'll have both your scenarios set up. And so that's what we call the ambiguous case. And it only happens when they give you an acute angle and 2 sides that don't surround that angle, meaning the side across from the acute angle and one other side. That's when you have this potential ambiguous case. All right, so I'm going to leave it to you to find the last possible sides for little c, and then when you print the notes, you can check your work. So again, let me know if you need anything. I hope you have a great week.